bought this BT30 milling spindle online, and it's way more solid than I expected it to be. And for starters, I just bought this thing here, which has got a Morse taper in there, so I can put a regular drill chuck in there. But this sticks out an awful lot. So I figured it would be much better if this drill chuck just mounted on here directly. So I bought a drill chuck with a BT30 spindle on it, this one here, but this one sticks out quite a lot too. Not quite as much as the other one, but still more than I'd like. So I think I'll have to buy some collets and a collet adapter even for drilling. But before I do that, I want to make sure my idea actually works. And before I can try anything, I need some kind of a drawbar, which is essentially a long bolt that screws into here, goes through here, and pulls that in tight so that it doesn't fall out. Time to get my metal laid out to make one. This is a 1/2-inch bolt and it's long enough, but the wrong kind of thread. So I want to mill off this head to make an M12 thread that goes in here. That's down to 12 millimeters now, and I just tried a tap in here. The M12 by 1.75 is the right one, so that's the pitch I need on here. Got my gear set put on there for a 1.75 millimeter pitch thread. And I rather hand crank for thread cutting, but my bolt actually sticks out quite a ways in here, so this crank doesn't fit right now. Cutting threads on here without being able to manually crank it is just awful. So I'm just going to use what I've got so far as a starting point for using a regular thread cutter. And with a thread already established on there, that went really smooth. And now with a couple of nuts jammed together on the back of it, I can use this as a drawbar. And mount this in here. And I can finally see how well this works. That's not too bad runout wise. Oh, a little worse when we get to the front. Let's try something in the chuck. Oh, not great. If I want this to be practical for drilling, it needs to move in and out of the stock, preferably up and down. And that's where we're going to build this frame here with vertical supports here and these linear bearings that will allow motor and drill head thingy to move with it. And that's where the weight is a bit of a problem. So I got to counterbalance that weight somehow, and I bought a bunch of screen door springs to lift it. It'll probably take more than those. And this joint will be a triple mortise and tenon joint, but that'll actually be the weak spot. So I'll add this block here to widen that joint and give it more strength. And cutting the mortises and the base pieces, I'm removing most of the material just by plunge cutting in there. That way the end of the bit can cut into side grain in the wood, and I also get a lot less bit deflection. But cutting those 3 mortises, that actually took 3 minutes. I got some test tenons to go into those mortises, and these ones are too tight. But my second test, this one is just right. I'm cutting away the material between the tenons using a 3/8 inch router bit, just passing through with my slot mortiser. And to make that slot a wee bit wider so the tenons actually fit, I just take one more pass with this screw adjusted by this much, which widens that slot so the tenons fit. And this triple tenon would have been an awfully complicated panther rotor template, and to cut it with my tenon jig, the saw blade has to cut into the end grain, and especially in hardwood, it really doesn't like that very much and it's slow going, whereas the router bit, the way it spins, is cutting to side grain,
so it has a pretty easy time to cut that.
And then these things go up here somewhere like this.
And now I just got to cut a whole bunch more mortises into the sides of my L bracket pieces so I can join them together. And I'm also using the slot mortise to cut the tenons on the pieces that will join those two frames together because that worked out so well for the other tenons. It's a very rigid machine, so it actually cuts these nice and accurate.
These two pieces are just there to have something to bolt the table to, and these two pieces are very important because they give the whole thing side-to-side rigidity. This is all dry fit, now I have to glue it.
I think I cut the joinery a little bit too tight, and I actually ended up using my strip sander to cut those tenons down in thickness a little bit after the fact, and that made the final assembly more manageable.
Uh-oh.
And this is where I discovered that with the tenons fully seated into the mortises, my brackets are not quite square, and I think the problem here is when I cut those tenons, I just put it on the slot mortiser without a square, just freehand looking at the end of it that it was square, and I guess I was off by just a little bit. So my solution was to just bang the joint into square, even though that resulted in tenons that are not fully seated, and ended up just filling that gap with a bit of sawdust and glue so it's not so obvious that I left a gap. And with those two side L frames put together, I can now glue in the mortise and tenons for the pieces that connect them. It's not so much about how many mistakes I made, it's a matter of how many mistakes do I leave in the final edit. Never glue up anything without a big mallet close at hand. Gotta check that it's in there square, otherwise the next step of assembly would be much harder.
Much better.
And then dry fitting the other side on there to make sure that the glue doesn't set crooked. I don't want to glue both sides at the same time, that's just too much stress.
And now I have to build something so that the spindle and the motor can move up and down with these linear bearings here. I need to mount these linear bearings on this piece of plywood very accurately. And this is where this plywood spacer I made I think will help a lot. If I just glue that on there, I can just make sure all these are in the corners and they'll be in the right spot. This is going to mount on this piece of plywood, and to make sure this can't slide around a bit, I'm just going to glue some pieces of wood on either side of it. Now the glue on this is dried, and I'm just going to mark where the holes go for this just a tiny bit inwards so that the linear bearings get pressed against the stop here.
And I drilled those holes too far in, so I have to make some slight adjustments.
Missed the line. So these rods slide in there pretty nicely, but just checking that I'm parallel, when I slide this back and forth, it is evident that they are not. Oops. Yikes. 2 millimeters out. How did I screw this up so bad? So it turns out these are not all the same. This one ends with almost 0.2 millimeters. This one is 0.3 millimeters less wide, but worse than that, they're not symmetrical. So this is here, and that's here. So this is half a millimeter difference between here and here. Oh! And it gets worse. So checking this measurement here ends with 0.68. Measuring here ends with 0.05. So the shaft doesn't go through parallel to the casing. Ah! And I also just noticed I didn't get this block in there square, so I just thought I'd do a quick check, and it's not that my slot isn't square, that frickin' block is not square. Because it seems I care about price way more than quality, I shopped AliExpress. I guess I have to put this together the Chinese way, with bigger mounting holes.
I also measured the side offset of all my bearing blocks to figure out the best arrangement to best cancel out the inaccuracies. And I also had to make some changes to my very accurate stops to deal with the very inaccurate bearing blocks.
I cut out the spacer to be exactly the way I want these bars spaced and cut it down the middle. So now I can put that here and here to ensure the bars are parallel, and then with the bars parallel, I can tighten down the screws to hopefully get this all adjusted correctly. So this still moves 0.05 millimeters, but I think I can live with that.
And now I can use those same spacers to make sure I have the rods mounted exactly parallel on the frame. And also going to make sure it's square to the base.
Uh-oh. Need to bring these in somehow, but I don't have a good way of adjusting these now. Uh-oh, too tight. The center of the spindle needs to be at about this level here, so I need to make some spacers to go underneath here. I glued my spacer on the back of this piece of plywood, but not before installing T-nuts, which I'll need for installing the spindle block. And now I'm just going to make sure this is going to be square to the base. I now have almost 13 kilograms pushing down on here, but I still need to add the motor. Now we're at 19 kilograms. Oh, and plus tooling, 21 kilograms. Oh dear. Now this motor needs to go back here somewhere like this. And for belt tensioning, I figure I could just maybe pivot it something like this. So I need some kind of a bracket to go on this side of the motor. So I'm thinking of making a bracket that fits exactly into this space here for registration. And to capture that shape, I'm just going to take a picture of it from exactly above.
Now to get the scale of that, I'm just going to select Calibrate Scale by Distance, mark 10 centimeters on the ruler, and then tell the program that that's 10 centimeters. Next I select the area that I care about and crop it to that. And then I send it to the printer. These cheap inkjet printers are surprisingly scale accurate.
And here's my exact one-to-one printout. I've been working out a shape for a bracket to hold a motor that fits like this. And I traced that onto a block of hardwood. I removed that head assembly again and took it apart, and here's my motor mounting brackets, and now I just need some way of forcing the motor this way for tensioning the belt. Nice thing about a tight box joint like this is it sets up really quick, so I don't have to wait for the glue to dry. The ends of these screws fit into holes on the side of the motor like this. Motor mounted, and the closest belt I could find was too long, so the tension adjustment is kind of extreme right now. And I got a chuck on there, and checking the force on here, I'm at almost 24 kilograms or 52 pounds. So I really need something to counterbalance that weight. I measured those screen door springs and they can hold 6 kilograms each, so with 2 on each side, 4 in total. Let's see if that can actually hold it up. Oh, not enough spring extension. Need more spring tension. Woohoo!
And now just using a wooden stick to get a sense of how much leverage I need for the handle.
So I need some way of adjusting the base tension of these springs for how far this thing reaches equilibrium. So by turning this, I can wind up that string, and this part is the wrench. And this pin in here locks that shaft in place. So I should be able to wind that up under tension. For my plunge lever, I figure I'll use a rack and pinion, and I'll make that with my gear generator program. And I decided on 24 teeth for the gear, and I need that to be 18 centimeters of pitch diameter, and I don't need any spokes on it. And let's make the other one a rack instead of a gear, and zoom out so I can see that, and now I can print that. I actually cut a few teeth off of that partial gear, so that way if I lift the handle all the way up, I can disengage and reset where it engages to get a more comfortable angle depending on what height the head is at when I'm working with it. funny how quiet this machine is too. So I hope to eventually mill with this once I get the right kind of collets, but overall the machine is far from done, but what is done is this video.